Yeah.
Okay, welcome everybody. This is June of 2025 and we're into our sessions here just a little bit. I want to welcome our Facebook friends, and Mary Pomberg is nicely holding the phone for us to do this live stream. We also have Mary Baldwin in the back here videoing, and she will be putting it on YouTube in a couple days. And with her what she's taping, she will also have the screenshots a little closer, so if you miss something or get cut off or aren't available to listen here tonight, the YouTube will be on her web page, Lansing Office Works. Yep, in YouTube format. And the live stream on the phone will be on for about 30 days. And with that, thank you for attending, thank you for coming, and thank you, Clayton, for your presentation, and introduce your new staff tonight, will you?
Sure. Thanks, Derva. So anybody new here? Hasn't been to one of the bridge talks yet? Thought everybody looked pretty familiar. So again, I'm Clayton Burke. I'm the project manager for the Iowa DOT, and with me I've got Travis Conda, HNTB's project manager and structural engineer, and we have a new person with us tonight, Ryan Kolsrud from Walk On. He's our intern for the summer, so he's really been grabbing the project by the horns and picking things up really fast. So he'll be with us until he heads back to Iowa. So tonight, what we're going to do is go through a quick progress update on Pier 2, the work that's been going on at Pier 1, the bridge approach decking, the west abutment, and the steel erection progress. After that, we also have a quick demonstration outside. Hopefully it's not raining or anything. And then we'll let you all go. So to start, we've been making progress on Pier 2. This is the pier that is out in the middle of the river next to the existing bridge. You can see this is the footing that we talked quite a bit about in our previous meetings. And we now have the first section of the columns poured. So these yellow platforms are the formwork, and then you can see the concrete just on the inside of that formwork peeking out. So it's the columns, and then we call this middle section that has, we call it the saddle, where it looks like an upside down arch, kind of. So we have the first portion of the columns poured, the saddle, and now we're going to start working on the intermediate portion of the middle portion of the columns and the pier cap. And to speed up the construction a little bit, we've actually decided to pour the middle section of the columns and the pier cap all at once. So that's a little more complicated. It takes longer to get the formwork set up and to get the rebar tied, so it's a little more difficult. But what we will see is that if you remember from the footing and the columns, these are mass concrete elements. So we really care about the internal temperature, and we monitor it. We even use cooling tubes on the inside to make sure that the inside of the concrete doesn't get too hot. We're going to do the same thing with these columns and pier cap, but if we combine these two together, that means there's only one period of time where the concrete is curing. And so instead of pouring a section, waiting a week for it to cure, then pouring another section and waiting another week to cure, we're just pouring one big section, and then we're only waiting 1 week for that section to cure. So moving forward, that's where you'll see out at Pier 2, we've got the formwork pretty much all the way to the top. It's a little more advanced than this today, but we wanted to show you. So if you remember Pier 3 on the Wisconsin bank, there is a nice arch in the middle of the pier, and it's challenging to form and to get just right, especially when we require a little chamfer on the inside, so they've got to do some fancy work with some filler in that area. But they did a really good job. They got that formed up. The rebar all fit in there, and it's pretty close to being ready to go. Oh yeah, another thing we haven't mentioned. Travis has been doing an awesome job working on the scale model of the bridge. We've got the shelving up that'll in place where it's going to be. I think, Travis, you said you're still going to take it down and sand it and varnish it. But this is where it'll be located, and these are the piers that Travis has. Again, a scale model pier that Travis has made. And you can see the internal arch on the 3 piers, and then the saddle on the bottom, and the 2 columns on the outside. Yep. So here's kind of what it looks like today. You've got your support struts holding up the formwork on the top, which is very important because when you pour concrete, or that much concrete at a time, in that amount of depth, that creates a lot of pressure. So the formwork has to be held in place with some very stiff pieces, and to make sure that it doesn't blow out when we pour that concrete. So here we can see Pier 1. This is right on the Iowa Bank, right next to Front Street and the railroad. Here again you can see the rebar sticking out of the footing that's ready to connect the footing to the lower column. And in this middle section you can kind of see the shape of the saddle, and then on the outside these are the beginnings of the columns. What we had to do for Pier 1 again is drive a cofferdam around it so that we could pump the water out and work on the drilled shafts and footings. So today, or not today, but after the construction of the footing, that cofferdam was still in place, and we had to take it out, which wasn't too bad for most of the sheets. But so typically you'll just grab the sheets with a vibro hammer or vibratory hammer and then pull them out one by one. On the Iowa Bank side, there was some concerns that pulling the sheets out might allow the bank to move a little bit or to slough just a little bit. And so to be extra cautious and make sure we're protecting the railroad tracks and that nothing moved around, we decided to cut the piling off about a foot or 2 below ground level. And then after we were ready, we backfilled everything with riprap, kind of like you've seen along the riverbank in places where we want to protect the bank from washing out. This is about 4 feet of riprap, and we put it on top of a tough fabric called engineering fabric, so that'll hold the soil in place underneath the riprap, and this should protect the bank for the next 100 years. Then we've also got the lower columns that we're working on currently. So again, these are the forms, the big yellow squares that go around the footing and the columns. The rebar here is tied, so you can see it sticks up, and this will stick up into the middle column portion, and then they'll get those formworks around the rebar, and we think maybe early next week we'll be pouring that. I don't think we're pouring that this Friday. So coming up very soon, we'll have a pump truck sitting on the roadway under the bridge with another pump truck next to the columns, and then we'll pump the concrete over the railroad tracks and fill the columns up. We've also been working on the Wisconsin approach bridge deck. So this is on the Wisconsin side. This is where the bridge comes down and touches down next to the existing Wisconsin 82 roadway. So these are the concrete beams that we've talked about in the past. They're about 5'3" deep, and they're about 120 feet long. So we got those. So we set those on top of the piers, and then after that we got the decking in place. And once you have the decking ready, then you're ready for rebar. It doesn't like this side. So here you can see we've been tying the lower mat of rebar. So in a bridge deck, you typically see a lower mat and an upper mat of rebar. And that adds to the strength of the concrete and distributes the load to the beams. So this here is just the lower mat of rebar, and then these hoops you see over here are protrusions, or they stick up into the barrier rail or the traffic rail. And so they're setting those up as well to be poured into the bridge deck to make sure that you have that strength that that traffic rail needs. Another interesting point, you'll see that this is fairly shiny and silver rather than green or rusty black. We are using stainless steel rebar in the bridge deck to as part of the 100-year design life of the bridge. So we had an option to either use regular epoxy-coated rebar and a much higher strength concrete, or we could use the stainless steel rebar and a normal concrete mix that has plenty of strength. And the easier option was to go with the normal concrete mix and the stainless steel bars here. So this is what the paver looks like for the bridge deck. It's often called a bidwell. So this will get set up on rails along the side of the bridge deck, and then there are augers that you'll see that distribute the concrete and a plate behind it that goes back and forth, and essentially like a bull float, it smooths the concrete out behind the paver, and then we'll cover it all with wet burlap and let it cure for a period of time. So a pretty simple machine. You can set your crown, which if we haven't talked about crown yet, but you can see it in this next picture a little bit. So here you can see they've got the top mat on now. So they have both the lower and the upper mats of rebar tied. And the crown is just, if you made a roadway completely flat and it rained, the water would just sit on top of the roadway. So to prevent that, we construct our roads with what we call a crown, or it's just a little bit of an angle that meets in the middle. And the bidwell has some adjustments to meet that crown. You can see here it's not perfectly flat. There's an angle on this side and an angle on that side, and that's how we form the concrete to meet what the rebar is tied to and to form that crown. And again, here you can see that nice shiny sheen. The contractor did an awesome job tying those nice and even. You can see how smooth that looks. And then if you're wondering, these boards sticking out are just to hold down the outside deck. So if there's a big wind event, this doesn't blow up. It doesn't get caught by the wind underneath and blow up and move around. Those boards just hold everything down. So to get ready for the bridge deck pour, we have to do what we call a dry run, and that's when we set up the paver and then we run the paver without any concrete, and then we can check to make sure it has the right depth underneath the paver as they go across the bridge deck. And you also check to make sure you have the right clearance between the rebar and the paver so that your rebar is engaged the way it's supposed to be and protected from any saltwater infiltration or things like that. We're also working on the west abutment. So this is on the Iowa side again. This is up by 2nd Street, and you can see that we've been working on what we call the abutment. And that's just a word for the footing or the concrete structure that the end of the bridge sits on. So this is where the bridge touches down, and we are using plywood formwork instead of the metal formwork in this case. And then we have the green epoxy rebar in this location because it's under an expansion joint, so there's a good possibility that salt water will drop onto the surface of this footing. So we use a rebar that has some protection on it. You can see the nice cage that was tied up, and then we have these big tie-down bars, which are these black threaded rods that you see here. And those are kind of interesting because when we put the steel truss on the new bridge, there's going to be a point in time where part of that truss is hanging out over the water. And when that's hanging out over the water, it's actually going to lift up on the abutment. So this abutment is designed for what we call uplift. And it's pretty common to think of a bridge as pushing down on all these structures, but in this case, it'll actually, for a period of time, be pulling up. And so we have some nice big bars to hold on to the steel truss, and there are extra bars in the drilled shafts to also give it some strength for that lifting. So we got the formwork all done, the rebar was in, and we poured this recently. So here you can see the concrete trucks showing up and the pump with the big green arm. We were able to, it was about 100 yards or 100 cubic yards, which would be about 10 concrete trucks. And it went pretty well. And then this is what it looks like at the end. You can see the nice smooth top to the concrete and those tie-down bars sticking out. And after we're done, we put a clear plastic over the top to help keep the water in next to the concrete so that it cures correctly and we don't have or shrinkage cracking or anything like that. And so I'm sure everybody's pretty well aware. We also had a recent closure of the bridge. And so what happened was I got a call at 10:30 at night on a Saturday, which is not much better than getting a call on a Sunday. And it was a call that the displacement monitors had sent an alert out that the bridge had moved. And it had moved past our safety thresholds. So we had to immediately close the bridge down and reevaluate it. So the next day, on Sunday, we had a surveyor out there already. They were able to, jump right away, get out there, and verify that the bridge did indeed move about 1.5 inches to the north. And this is just one pier. It's Pier 3 that moved. So we verified the movement with the survey, and then the next week we had our engineering firm come out and inspect the bridge to verify if any of the members looked overstressed or if there was any signs of damage, anything like that. So the engineering firm came out. They did not find any issues. And then we continued with a plan forward. So the bridge had moved past the safety thresholds. We no longer knew what the capacity of the bridge was. So we had, after the inspection, the engineering firm use that information to update their model that they have of the bridge. And when they incorporate more accurate data and they can perform a deeper analysis, which takes more time to get into, they can come up with a more accurate rating of the bridge. And after they updated their model with all that real world information, they found that the bridge still had plenty of capacity left and we were able to reopen it. It did take some time and we didn't know the outcome right away. I know there was some frustration with information coming out and we're stuck waiting for that report to come back that told us that the bridge still had capacity so that we could open it. So we are working on getting ready for steel erection as well. So that Saturday, while during the day, we had been working on what we call temporary shoring towers. And these are towers that are going to support the middle of the steel truss while we're building it. So it can't support itself until all of the different pieces are put together. And so we need these towers to set it on until all the pieces are all connected together and tightened. To do that, we're driving piling down to bedrock for those towers, and we got about 4 of them in that day, and then that night we had the sensors go off. So we paused on the pile driving for now. We are waiting for some more analysis from our engineering firm to give us even more accurate information on the bridge. And then we plan to continue construction of the new bridge in the future after we get that more detailed report. For now, the towers are on pause, and we will be waiting for we might be waiting for the steel to show up, or the steel might be waiting for the towers. We'll have to see. So these towers here, you can see the start of one of them right here, and the 4 pilings sticking out. Those are sticking out of a frame and what we call a template, and that template just helps us locate where the piling go. And then you can see 2 other templates on the west side that are ready as soon as we have what we need to continue construction. I forgot this side doesn't work.
Is there any idea how long you'll be waiting for the engineering report?
It seems like a few weeks, so that's why we've said we'll likely resume the closure after the 4th of July so that we can continue the construction.
Question?
Yeah.
I assume piling 3 is in the middle of the river on the old bridge as well. Is that right? The one that moved an inch and a half?
Yeah, it's not directly in the middle. Pier 2 is the most centered existing pier, but this is the one just to this is the one. This is Pier 3 that you're looking at. It's the pier that's just to the east of the pier in the middle of the river.
So these steel pylons, because you were pounding them, that's why you think it moved?
We don't know exactly what happened. We can't see under the sand to see what actually happened with the pier, but it does seem to align with the time period in which the movement happened. So.
And how many more of those pylons do you need to drive in order to continue according to plan?
So we need to drive we need to finish the 4 that are in the ground, and then we need to drive 16 more. But the rest of them, these are the closest ones to the pier. The rest of them are further away, except for at Pier 4, where there's another shoring tower that's in fairly close proximity. Yeah.
Movement of the bridge, what caused that?
Like I said, we can't be absolutely certain. It seems to line up pretty well with the driving of the pile, but again, you can't see underground. You can't tell what's happening with the foundation, and we don't know what that bridge is actually sitting on, other than there's accounts that say that there are timber pile that stick out of the bottom about 40 feet.
Wasn't there analysis done before you started that area? And it came through, or that should have told you that you got problems there?
Right. So last year, before we invested any money in the repair that we did for the first movement, we knew we had to continue construction. So what we did was we went out with some piling in these locations. So last year we drove a pile exactly next to the pile for that template. to test the sensitivity of the bridge. If we drive these piling, would it continue moving? And last year when we drove these piling, we call test piles, the bridge did not react at all. So we're not sure why it moved this year, what's different, but we had confidence based on that test piling that we could continue construction.
Have you thought of doing a different type of testing that would give you some better results?
Like what kind of testing?
Ask an engineering company.
We've been working very closely with several professional engineering companies, and there haven't been any recommendations to do any further testing or that there are any other further tests available.
Did they tell you that what they have wouldn't give you the information that would prevent this from happening because their testing is not that good?
Who's testing?
The engineering testing, you just said that they did the best they can.
Right.
Well, if the best they can doesn't give the results, then maybe you shouldn't. Okay. Well, you got an issue going. You got an issue.
Yeah. We operated off the best information available, and we ended up with.
Best information did not confirm that the results you wanted would be there. And it didn't because it moved.
Yep. We don't know why it was different. And nobody else seems to know either.
You wasted a lot of money.
I wouldn't say it was a waste or relative, but it was a decision, yeah.
You said that after the 4th, you're going to shut the bridge down and keep working. What does that mean?
So we have to continue construction of the new bridge. To do that safely, we're going to close the bridge and work on the piling next to it that you see on the screen.
While you're working on those piles.
Yep. Those are the last subsurface elements that we need to put into the river bottom. So we are going to close the bridge, work on these piling, and we're changing how the piling are installed. So instead of using a vibratory hammer, we're going to use likely a impact hammer with a big diesel hammer on the top and see if that changes anything. And we're also going to change some of the timing of the installation. So instead of driving 4 of them in a day, we may drive 1 or part of 1 in a day, which will all slow down the process immensely, and it'll take much longer to install the piling, but we're doing everything we possibly can to minimize the impact that this has on the existing bridge. And so it'll take more time and money, but it'll minimize our risk of that bridge moving again. Yeah. So, yeah.
What was the pier that was repaired? Is that pier 4?
Last year,
Yeah.
that was piers 6 and 7 on the Wisconsin approach. Those were on land. Yep. And that's where we were able to actually lift the deck spans off, set them on the side, and completely replace the piers. So I think we already talked about the inspection. This is what some of the modeling looks like. So we get into what we call a finite element model. And essentially what that means is just that the engineer develops a model incorporating every single little piece of the steel truss of the bridge, and then they can use that model to move the pier or to change something and see how it reacts. So that's what they're doing with the movement of Pier 3. They put that into their model, and then they can see how each individual member, how it reacts, how much stress it has compared to its capacity. And that's part of the report we received, was just seeing the model and seeing that it still had plenty of capacity left and which members were really overstressed, which there were none. So to continue forward, like I said, we're going to continue monitoring the bridge. We're actually installing more monitoring devices. So there's a tilt meter that's going on there that reports more often. So Travis, was it every fraction of a second or every 5 seconds?
Much more sensitive.
And it's more sensitive. So we'll put that monitoring equipment on there so we can tell exactly how the bridge is reacting when we continue driving the piling. And then we also, we're going to monitor it and continue construction and see how the bridge reacts. So any other questions? Yeah.
How long could that be in July? If this all looks good, considering if you get to go ahead, what are we looking at?
Honestly, it probably could be a couple weeks to a month if the piling are going in without the bridge moving. But there is a real chance that the bridge might not be able to be constructed next to the existing bridge, and we would have to leave the existing bridge closed until the new bridge is built.
I think that's something you'd know this summer, probably.
Yeah, in July we should, as soon as we start driving those piling, we should know exactly how the bridge is going to react. Yep. Yeah.
My understanding is towards the end of the process, there's going to be a bridge closure to do some final things with the approach.
Yeah. Some of the roadway work.
Yeah.
Yep.
And, I mean, is there, if there's like, say, a bad case scenario where we have to close the bridge, is there other adjustments to the, well, I guess what you said is the worst case scenario is the bridge is closed until it's done.
Yep. So essentially we would switch to demolishing the existing bridge first. And so we would have to demolish the existing bridge, finish the shoring towers, and then continue with steel erection. And you'd likely see work would be able to progress on the span on the Iowa side while we were working on that. Possibly when we're working on the demolition, I'm not sure. We don't have a demolition plan in place because we're not to that point in the construction schedule yet. But we'd have to see what work could be done while we're waiting for the demolition plan, and then also while the demolition is taking place. Yeah. Yeah.
So let's say you gotta shut it down. Good case scenario, could the whole job go faster?
Potentially, there are ways we can what we call acceleration or speed up the project. So we could work longer shifts, weekends. We could bring in more equipment, more crews,
Seems like
and
maybe a good plus to it, I guess.
the erection might go faster if the existing bridge isn't there. So there are, yes, many possibilities that the construction could go faster. And that's what we would do, is go as fast as we possibly could to get the new bridge open at that point. Yep. Any other questions? Yeah.
Is there a way to possibly brace Tier 3 off of the, what I call the large bumper?
Oh, the protection cell?
Protection,
The dolphin?
Is there some type of bracing, you know?
No, that's an interesting idea. I think, if we had,
Yeah,
I think, where's the other picture? Yeah, so if we put some bracing between this dolphin and the pier, that's quite a span. So you'd have a long distance of unbraced support.
that's the
And
closest one there.
Yeah, so you need a fairly substantial member, and I'm not sure what all would have to go into that design. And it'd also have to cross the shoring towers. So there could be some conflicts there as well. But no, good thought. Any other questions before we head outside? All right. Let's go get some fresh air, and we're going to check out a little demonstration on what we've been working with here. Hey, Bill.
Say again a question.
Yeah.
Because these forms are quite a ways apart because of the thick columns, do you have tie rods that connect one set of forms and they go right through the pier, right?
Yep. Exactly.
So you snap them off, and then you grout the whole,
Yep. Cover them up and
pretty standard.
like they were never there.
Pretty standard stuff.
Yep. They're pretty thick tie rods though. They're a lot to cut through. Yeah.
It's too early for this question, but like in California, they have concrete bridges and stuff like that.
Mm-hmm.
And recently, I just saw, I think it was just recently, they were fixing the bridge because there were potholes. I know it's too early to ask that question, but are we going to have to worry about later down the road about our bridge having potholes on the concrete?
So no bridge deck is going to last forever.
Okay.
And how we maintain a bridge deck is we'll typically it'll have a lifespan of 30, 50 years,
Okay.
and how good the construction is. And at that point, you may start developing potholes, or we may catch it before it gets to that point.
Okay.
But we can do some patching, and then we'll do what we call a bridge deck overlay.
Okay.
And so we'll grind off the top, two bridge deck, and then we'll come back with the concrete paver and get a brand new deck
Okay.
on top. And that's how we kind of maintain the bridge deck so
Alright.
that we don't have potholes.
All right.
Yep. All right. Everybody make it? We got Lori. All right. So just a quick demonstration on some of the challenges we've been working with having a structure in the sand that's not founded on bedrock. So what Ryan's going to do here is we have what we call a vibrator, and usually you use this with concrete, and you stick it in the concrete to get it to settle out and have all the air bubbles come up to the surface, so you have a nice smooth blemish-free concrete surface on the outside of the forms. And we also use it to get the concrete to flow around the rebar, and so you get a nice uniform product. But here we're going to use it to kind of demonstrate a pile that's going into the ground, and then how the foundation reacts that's next to that piling. And so Ryan, if you want to start it up, and we'll see how it goes. So you can see as soon as the vibration starts, this starts singing. That's good. So I'm not going to go into the geotechnical engineering of it, but the sand starts to lose its support. And so what I really wanted to show is the closer you are to the vibration source, the greater the impact that it has on the structure. And so that's something that we've really been struggling with. So these sections back here are relatively in the same place. So what is that distance between the source of vibration and the structures that did not move? And so geotechnical science isn't an exact science. We've worked with engineering firms to try to figure this out, but it's very difficult to have a sand that's not a uniform product. So that sand has different materials in it. It changes every foot that you move around, and it's different from top to bottom, and it's very difficult to model. So it's a challenging science to figure out, but that's essentially what we've been working with, is how close is too close to the existing bridge. And like I said, we've done the test pile program. It didn't move, so we had some confidence that was not too close. But then this time around, it had an effect on the existing bridge. So, any questions on driving, piling, or vibrations near the structure?
When did the state know that the existing piling didn't go to rock?
We don't know anything for sure, but there are historical documents that indicate that the piling only go 40 feet in the ground. But we don't know how many, we don't know what orientation they're in, so we can't take that and put it into a model and say exactly how that structure is going to react.
Yeah, okay.
Yep.
Thank you.
Because this was a private bridge built by a private company, and when the states took it over, they did not turn over the as-built plans, so we don't know exactly how they built it. We can measure everything above ground, but we can't measure anything below ground. So, yeah. Any other questions, or feel free to come up here and,
When you pour
yeah.
concrete on the Iowa side and the pumper goes over the track,
Yep.
can a train go through while that's happening?
No. So we have what we call a railroad flagger. That's a railroad employee that's on site that monitors train traffic, and so it's a very important role. He'll tell us when a train's coming, and we have to get that pump turned off the track and set to the side so the train can come through, and then after the train comes through, they can go back and swing the pump back out and continue the concrete pour.
Wouldn't the concrete harden in the pumper?
So it doesn't take that long, and the concrete has quite a bit of what we call retarder in it, so it doesn't harden as fast. It takes quite a while, and I guess we haven't run into that issue. Yeah. Any other questions? Yeah.
Do you guys have a super special prayer that you say every night? That none of this is going to happen again?
You better believe it. Yep. Exactly.
We'll do it too.
Okay, thank you.
Yeah, tell us so we can say it too.
Yeah.
Make it your own.
Please, please, please. Any other questions? All right. Well, thank you all for coming out. I appreciate it.
Thanks for being
And
here.
yeah, thanks. Got a pretty nice night
I saw you when you were on NBC News. It was so exciting. I was watching TV. And
on
all of a sudden-
NBC.